Video, the addition of electrons is called reduction, while the loss of electrons is called oxidation, and oxidation results in cations, and cations move away from the electrodes towards the electrolyte, while the anions move towards the electrode in the direction of the electron, and current flows in the opposite direction. Okay, so N is the valency of C, M is the valency of A, and these are the frequencies of different biological signal: ECG, EEG, EOG, ocular, muscular, encephalogram, cardiac. So art, this simply art, brain, eyes and muscles, and their amplitude and frequency ranges. Okay, so what are the properties? It should be a good conductor, it should have low impedance, because already signal is very low. If you have high impedance, signal is gets fully dropped. Should not polarize when a current flows through them, that means they should not dissociate. Should establish a good contact with the body and not cause motion. Should not cause itching or swelling discomfort to the person or the patient. Metal should not be toxic, mechanically rugged, easy to be cleaned. So electrode skin interface. So interface between the body and electronic measuring the system. The conducts current across the interface. Ions carry current in the body. Electrodes are capable of changing the ionic into electronic current. So electrode, electrolyte, or electrode termed as electrode, electrolyte, or electrode tissue interface. Okay, so you have the instrument, you have the electrolyte, you have metal electrolyte interface, electrolyte skin interface. Okay, so at every level you can model it as required as a equivalent circuit. So there will be a capacitor circuit, there will be a resistance circuit. So what is the function of capacitor? They store charges, because electrode, when current flows, there is a dissociation into charges or dissociation into ions. So they they have ions, charges, and there is a restriction to the path. These are in a parallelly this thing. So, and even in the electrolyte gel, there is a resistance, and this different voltages, or basically the voltages that is developed at different are developed at different levels, due to that when the ionic current is transferred, okay, as an ionic to electronic current, these are voltages at various different levels. And you have this epidermic and gel. So this together can be classified as another capacitor and skin and resistance circuit. Okay, so when there is an electrode, the first fundamental circuit that you should draw is a capacitor and resistor circuit with a voltage source. Okay, and this voltage source will be then be coupled to another similar when there is an electrolyte or when there is a tissue, as shown in the figure. Okay. So offset potential, the potential difference that is caused the ability of the electrons to flow from one half of the cell to other. Electrons are able to move between the electrodes as a chemical reaction is a redox reaction. Offset potential is altered when the current flowing in the electrode due to the electrode polarization. When the metal comes in contact with the solution, the electrolyte surrounding the metal is at different electric potential from the rest of the solution. A second electrode is required to find the offset potential, such as hydrogen. Offset potential is determined by metal involved, concentration of its ion in the solution, and temperature. Nernst equation we saw in the previous video, that is the ratio of to find the equilibrium potential to stop the flowage of ions between the cells from inside to outside the cell. We need an equilibrium potential, that's given by Nernst equation, which is the ratio of concentration inside to outside the cell. Then comes polarization. Normally, the standard offset potential is an equilibrium value and assumes the zero current across the interface. When the current flows, the offset potential E0 changes. The over potential, difference between the non-zero current and the zero offset potential, also called polarization potential. Ohmic over potential, due to the resistance of electrolyte, the voltage drop along the path of the ionic flow. Concentration over potential, due to the redistribution of ions, the vicinity of the electrolyte interface. Activation over potential, due to the metal ions going into the solution, must overcome the energy barrier due to the metal plating of the solution onto the electrode. Okay, so these are some important concepts or definition that you should remember, or you should understand when you are defining about polarization. Okay. So mechanism of over potential. So there are different over potential. Voltage drop along the path of the current, and the current changes of the resistance of the electrolyte. Thus voltage drop does not follow Ohmic law. So this is the ohmic voltage potential, and then the concentration, current changes, the distribution of the ions at the electrode electrolyte interface. So at the electrode electrolyte interface, there are different potential. One is ohmic potential, because that is because of the electrodes, because the current changes the resistance of the electrolyte, Okay, so the resistance of the electrolyte changes, Ohm's law changes, then there is an ohmic over potential, then concentration changes, current changes the distribution of ion, concentration over potential, the current changes the rate of oxidation and reduction, the activation energy barriers for oxidation are different, net activation depends on the direction of the current. So the over potential is a combination of ohmic potential, concentration and activation, that is VR, VC and VA. So VR is the ohmic, R resistance, C is the concentration C, A is the activation due to the oxidation, that is dissociation into electrons, and the electrons flows. So you have an electrolyte, right? So what is the purpose of electrode? That converts ionic into electronic current. Okay, so what happens in the electrolyte? There are ions, and electrode is a combination of ions. It also it's a metal surface. Okay, it is a solid compound, and when it's placed on the electrolyte will result at that interface. As we saw previously, there will be a dissociation of these electrolytes into various different ions, and ions move to a specific electrode, and if there is only one electrode, that results in an off-cell potential. Okay, because there is only one electrode, there is no more than one electrode, that results in an off-cell potential, and this off-cell potential can be measured with another potential such as a standard cell, such as hydrogen cell. So this is an off cell potential, right? So you have an off cell potential, and the off cell potential further can be discussed based on polarization. Okay, so when you say polarization, what is polarization? And the polarization is defined with a term called over potential, and this over potential is further defined as VR, VC and VA, which is a combination of ohmic over potential, concentration over potential, activation over potential. What is polarizable? Perfectly polarized electrodes in which no actual charge crosses the electrolyte interface when a current is applied. The current across the interface is displacement current, and the electrode behaves like a capacitor. Okay, over potential is due to concentration, and when the non-polarizable is when the current passes freely across the electrode interface, requires no energy to make the transition. These electrodes see no over potential. Example, AgCl electrode. Previous example is a platinum electrode. Okay.